So, hello everyone. It's nice to see so many of you at this point of the day. I know it's last session for this room, so we'll try to make it as interesting as possible. So before we talk with SimuGreen, I will introduce myself briefly. I'm Arthur Vervet. I'm a PhD student at OUTSCALE in Big Data and Artificial Intelligence. And today I'm here alongside Maxime Dufour, which is open source developer at OUTSCALE too, and Julia Soloveva, which is a master's student at ISEP Engineering School and the University of Vienna. Let's move forward a bit. Before we talk about SimuGreen, I want to acknowledge here with you some of the tremendous aspects of clouds when it comes to saving energy. Because as you know, cloud platform explores a shared pool of IT resources and services. So it's reduce the needs for IT equipment because you can use it at their maximum potential all the time, and you can go for more efficient equipment and more powerful equipment in the end. Another interesting aspect of cloud is flexibility. Once again, shared pool of on-demand access resources mean you can easily transform your architecture, scale it, try a new type of architecture and things like that. And this is an important point for SimuGreen, as we'll see it later. So, probably in your social media at some point, you add this table with the power and efficiency of programming language. It's a research studies that was supervised by Professor João Saraiva from Portugal, and with some tremendous number like, oh, C is 75 times more power efficient than Python, things like that. The point of this talk is not to tell you, okay, let's code everything in C and Rust and drop down everything, because the choice of a programming language is complicated. But it's important to acknowledge that choices like programming language choices have an impact on the power efficiency of the final system. I talked about flexibility before, and we'll now talk about the energy efficiency aspect of architecture, and now I will go into SimuGreen. Because SimuGreen is a simulator, that's simple. You're providing it Terraform scripts with the targeted architecture, as well as some test scenarios regarding what you want to do with your services. And SimuGreen will output you the consummation of your services on your test. Like, okay, this is what my system is supposed to do. This is how my system is supposed to like. Deploy it on the cloud, run some benchmark, and send me a number, and this number is the total consumption of the system on those scenarios. So this allows you to try and benchmark multiple architecture quickly and get some results based on their power consumption. As Rajatis did this morning, SimuGreen is already accessible open source, and it has been first used in a hackathon. I will now leave the floor to Maxime so I can tell you more about this. So Maxime.
Thank you, Arthur. So the first big step of SimuGreen was the introduction into a hackathon organized by SagenCom, OUTSCALE, and ISEP. Last October, during 24 hours, 16 teams compete for the same goal, which is to reduce power consumption of a given service using SimuGreen. They all had the same assets, which were the source code of the service written in Python, the Terraform configuration to deploy the service into OUTSCALE cloud, the test code to make sure that if any modification have been made, all the tests pass, and then, of course, SimuGreen to actually estimate the power consumption of the service. So now let's talk about the finding during this hackathon. So first of all, some teams actually found out that if they only execute one time the estimation, the run test, if they got only one estimation, it's not enough, because actually we are in a cloud environment. Therefore, the virtual machine are on hypervisor, and on this hypervisor, most of the time we are not alone. Therefore, during multiple runs, we might get different results. Therefore, we need to actually execute multiple times to get the average number, the average estimation. Then let's talk about the strategy that they were using to actually reduce the power consumption of the given service. We can split into two categories: software optimization and hardware optimization. Then again, this is just a 24-hour work. Therefore, this is not a full shopping list to reduce power consumption. It's just some ideas. So for software optimization, some team use profiling of the service to actually identify which part of the code costs the most. And then they just use some method like simplify the code or refactoring. They use better algorithm to reduce complexity. Therefore, they reduce execution time and then power consumption. Then again, the service was written in Python. Therefore, they can use operations that are more efficient in the language. And the service was composed of three components: front-end, back-end, and database. Therefore, there are a lot of SQL queries that could be optimized or merged to actually reduce the traffic between those components and therefore the power consumption. If it's not enough to reduce power consumption, we can actually rewrite all the code or just some part of the code. In 24 hours, it's kind of difficult to rewrite everything in other languages, as Arthur said, in Rust or C. Therefore, we can just use some tools. For example, in Python, we can use CPython to go from Python to C binaries. Or we can use libraries that are compiled in compiled languages, such as C or Rust. There's also a third method that one team used, but it's not really a good real-life scenario. Actually, they removed the database because, I mean, we just think they just found out that if they remove the database and they just store everything in RAM, it works well and they reduce the power consumption. Actually, this idea is not quite bad. It's just to rethink the technology that we are using and maybe just use another framework that is more efficient and to reduce the power consumption. For the second kind of optimization, it's hardware optimization. We are in a cloud environment. Therefore, the virtual machine spec has a lot of parameters to tune and to change the performances of the virtual machine, such as the number of CPU, the quantity of RAM, IOPS, etc. And in this scenario, one of the components was the database, and a database needs a lot of input-output rate disk. Therefore, we need to make sure that this component has the best available disk in the VM. Then again, it's just 24-hour work. Therefore, it's not a full list of what you can do. I will let.
Yes, thank you very much, Martin. Even though in 24 hours with different approach, some teams were able to reduce by almost a factor of 10 the power consumption of the system that was proposed to them. I will now leave the floor to Julia because, as we said, the SimuGreen is in open source access, and Julia worked on it during his master thesis and do some improvement and more scientific work in more than 24 hours. So, Julia, it's to you.
Thank you so much. Hello, everyone, from my side as well. So during my thesis, I was working with SimuGreen, and basically I did 3 optimizations. So the first optimization was to merge virtual machines. So first I would briefly speak about the architecture of the project, which was used for the hackathon as well. So first there is a virtual machine with application which hosts the function. The second one hosts the database, and the third one hosts the microservice. So during this optimization, I merged the virtual machines, as can be seen on the graph. And now I would like to speak about the results and other optimizations. So Here, as you can see, first I measured the energy consumption of the initial platform, so of the platform which was presented in SimuGreen. Next, I merged virtual machines in and used the Python application, so this is the second optimization. The third one is I rewritten the code, I actually rewritten the whole code in Java, and I kept the unmerged virtual machines, so this is the third one. And the fourth is Java application with merged virtual machines. So as can be seen on the left side, we can compare all four cases. And also SimuGreen allows us to use four metrics, which are virtual machine consumption, idle compute consumption, traffic power consumption, and the total energy consumption, which is a sum of the previous three ones. So if we look at the graphic, we can see that the Java merged virtual machines perform the best. So now I would like to go for the details of this optimization. So comparing to the initial platform, rewriting the code in Java and merging the virtual machine resulted in virtual machine consumption energy decreased by approximately 64%. Next, idle compute consumption decreased by around 77%. However, I should add that traffic power consumption remained largely the same, and the overall energy consumption decreased by around 58%. So those results are the average results from 30 test runs. As my colleagues already mentioned, it was needed due to the nature of cloud computing. So now I would like to go to the next metric, which is also possible in SimuGreen. So basically, I also compared the execution time for all the four cases which I had. So here we have Java with merged virtual machines, Java with unmerged virtual machines, Python with merged virtual machines, and the initial setup. So we can see that the execution time could be also optimized by more than 50% for some cases. And next, this was all for my personal findings. And as for the future work for SimuGreen, so in the paper, in the scientific paper done by Portuguese scientists, they compare languages based on three objectives, so based on time, memory, and energy. Currently in SimuGreen, the comparison between the comparison based on energy and time is possible, but however, another module which could measure the energy, the memory consumption could be added as well. So this is the one way how to extend this project. And the next extension could be the represent the graphical data, represent the data in graphical format, since SimuGreen can be used by students, so representation in graphs such as can be seen on the slide would be also useful just to simplify the data. Thank you so much for this, and I will give the stage back to Arthur.
Thank you very much, Julia. Before we move to Q&A, I just want to acknowledge here the tremendous work of Evgeny last week, even though if he was not able to attend today, but he contributes a lot to this project, so thank you very much to him. And now we are ready to answer any question in English or in French. Est-ce qu'il marche?
Non, j'aimerais juste savoir, les études que vous avez faites, vous vous êtes basé sur juste des binaires ou vous avez pris le temps de compilation du programme, vu qu'il y a des langages qui sont compilés, d'autres sont interprétés. Comment est-ce que vous vous basez à partir de quand vous prenez le temps de consommation d'énergie?
Alors, pour le simulateur, on prend pas en compte la compilation. Après, c'est un facteur qui est aussi soulevé dans le papier des chercheurs qu'on a noté. C'est que le temps de compilation, on l'effectue une seule fois. Et généralement, il est assez négligeable par rapport à l'énergie que va consommer un système qui va tourner H24 sur une année. Donc, c'est pas forcément le plus gros facteur à prendre en compte. On pourrait l'ajouter à l'étude comme une surcouche. Mais c'est vrai que dans leur papier, même en l'ajoutant, au final, si on prend en conséquence qu'un système va tourner a priori 24 heures sur 24, ça sera négligeable.
Si le programme, c'est juste l'exécution ou en fonction de la charge du programme, je veux dire, pour une base de données, lancer une requête, pour une base de données, lancer une requête ou aligner plusieurs requêtes, il y a une grande différence ou juste l'exécution du binaire qui consomme ou en fonction de l'utilisation, je ne sais pas.
Je ne suis pas forcément sûr de la question. Est-ce que c'est...
Je vais dire la consommation varie énormément ou en fonction des requêtes pour une base de données, en fonction du nombre de requêtes envoyées ou juste quel que soit le nombre de requêtes, c'est la même consommation.
Alors, c'est toujours la même consommation par requête. Enfin, après, ça dépend de la requête, ça dépend de ce que tu fais. Mais là, par exemple, dans le cas du hackathon, c'était surtout le scénario où il fallait en fait initialiser le scénario. En fait, on faisait un clone de la base. Et par exemple, on venait juste read et après faire des inserts ligne par ligne. Donc, c'est pas du tout efficace. Alors que globalement, tu peux optimiser. Et en fait, de tout faire ça directement via la base de données. PostgreSQL le fait très très bien. Donc, du coup...
Puis même, on peut imaginer, il y avait la solution des candidats qui ont tout mis en mémoire, donc ça, pas une solution scalable. Mais par contre, ça peut aussi poser la question on pourrait s'intéresser à l'intérêt de bases de données mémoire comme du cache Redis ou ce genre de choses pour des cas pour cacher des requêtes ou le fait de la différence de bulker des requêtes par rapport à faire des requêtes simples pour étudier cet impact-là complètement.
Du coup, donc ça parlait de Java et Python, c'est juste pour savoir parce que par exemple, genre Java c'est très bien pour du unithread et Python c'est grave nul pour du multithread et genre ça marche pas forcément bien. Et du coup c'est pour savoir quand vous avez comparé, si vous avez comparé par exemple avec de l'asynchrone en Python qui est mieux par rapport à du multithread en Java par exemple, où c'était juste sans thread et genre juste du simulateur.
Il n'y avait pas de multithread dans l'architecture proposée, mais ça pourrait être effectivement intéressant de tester la différence entre les deux. Et pour clarifier la baseline du papier, comment elle est établie, en fait, c'est un set de problèmes de base qui est répondu dans tous les programmes. Et pour un peu éviter la question de est-ce que vous êtes sûr que vous l'avez bien fait, le papier a exposé bien sûr la totalité de ses tests. Et si quelqu'un pense qu'il peut faire du code plus optimisé dans un langage, il est totalement libre de l'intégrer à l'étude.
Vous avez dit que SimuGreen prend en entrée l'architecture cible, mais je ne l'ai pas vu en input. Quel format d'architecture, comment vous passez l'architecture à SimuGreen?
C'est un script Terraform.
D'accord. Est-ce que vous prenez autre chose que Terraform?
Pas pour l'instant.
Okay.
Mais pourquoi pas?
Okay.
Ça me semble pas mal. Merci beaucoup à vous tous d'être présents ici. J'espère que vous avez apprécié ce temps d'échange et une très bonne journée. Dans tous les cas, n'hésitez pas à venir nous voir à la suite. Merci beaucoup.
Merci pour cette présentation.